Hi! This video shows how the Norwegian hydropower operator Hafslund saved 1.1 million euro of maintenance costs by using Visplore. In one of their hydropower plants, a guide bearing in a turbine was in danger of overheating. The field operator saw a heat warning during the startup of the turbine. And also after the next startups, the bearing temperature kept rising and rising. When the explanation was not clear on site, the engineers in the centralized office helped with the troubleshooting, using Visplore. First, the engineers imported 8 months of operation data from the Aveva Pi historian in Visplore, about 30 sensors from the bearing and other parts of the turbine. Visplore immediately shows you some statistics and graphics for these sensors. Here we see the bearing temperature. First, normal operation, then a long standstill in summer for some renovations, and then the abnormal heating happened after this startup here. So the period after the incident was compared with a period of normal operation. The periods are distinguished using colors. And now we want to focus only on the startups and the time after. So we can select one startup and use the pattern search feature of Visplore to extract all similar patterns automatically. Here you'll see all startups overlaid. Here is not so much difference between orange and blue curves, but we can add a time context of 6 hours after every startup. And now we see that the orange temperature curves during the incident do not stabilize in the hours after the startups. Normally, they stabilized after 3 hours or so, but here they go up and up until the turbine is switched off again. So now the engineers knew the heating was abnormal. But why? Are some other sensors showing anomalies as well? The root cause analysis is also supported by Visplore. Looking at the data before the incident and after, the question is, which of the 30 sensors have changed suspiciously? So we select the steady state before and after the incident and compare them. And now Visplore shows a list of all sensors, ranked by how different they are after the incident. Both bearing temperature sensors are much higher after the incident, but the other sensors have not changed as much. For example, the cooler temperature. They stayed constant or even went down. And that means all parts around the bearing did not heat up. Only the bearing has heated up. And this helped the engineers conclude that the problem is with the bearing itself. All these comparisons can be done within a few clicks in Visplore. So the conclusion was that there was something wrong with the bearing itself. Hafslund could start to disassemble the bearing with confidence and saw a punctured oil film. Since this was discovered early, it was only a small work to repair the babbitt metal in the damaged bearing segment. Only one more additional startup would probably have caused big damage and at least twice the repair time, of 6 weeks versus 3 weeks. The avoided revenue loss was about 1.1 million euro. In addition, work and material cost for a bigger repair were also saved. And as we see here, the temperatures were actually lower after the repair than before the incident. Finally, Hafslund implemented these insights to improve the condition monitoring systems. Transient states like the startups are now considered better in the monitoring, scaling the value of the insights to 800 bearings. If you want to learn more about this or other use cases of Visplore in hydropower, please get in touch. Thank you for watching.